started having issues with this lathe the other day. It just doesn't start up right, it makes funny noises. The speed's starting to go up and down. It's supposed to be a brushless servo motor in the back. Haha, it's not, it's brushed. Seems to be, that's probably the cause. See, that's what it's doing, and then if you give it it'll take off, and then it starts wobbling all over the place. If you run it for a while, it gets better. This lathe's not that old. It's only 2 years. Of course, I use it a lot. We're going to consider putting one of our servo motor kits in this lathe too. I'm going to go back, pull the motor out, and see what I think about the brushless motor. See how it's getting smoother? It's supposed to be running much faster than that, though. It's supposed to be running about, this is actually, it should be running about 900. It's not. That potentiometer is also sticky. It's not very good anymore. It's starting to fail. We'll go and check it out. Obviously a brushed motor. See the vents in the back? That's also going to allow metal chips and filings to get in the motor, and it's going to short out the brushes. It's going to be problematic. That just makes me want to put a servo motor in it more. Open the case, loosen these 4 bolts, remove the belt. Next, we're going to want to remove this pulley. There's a little Allen in there. Make sure you unplug everything before you take this off. We're going to take the back off so that we can unplug the motor before we pull the motor out. Notice there's very little metal filings inside the case when we remove the cover. The motor is the wires in the back. The white goes directly to a 10 amp magnetic quick release circuit breaker. That's pretty good protection. We're going to start putting those in our servo motors if we can fit them. The other wire goes up to the rotary switch. Rather than pulling the rotary switch, we're just going to cut that wire and resolder it later. We tried just about every Allen wrench I have to get at those Allens behind there, and USA Allens and metrics don't seem to fit. Maybe it's just because it's tight. We're going to try to remove the whole thing and see what happens. Hang on, I'm going to get a different wrench for those. Oh yes, the 5mm ball head Allen. How's that? Get you right in there. Around the corner. Oh, there's a nut on the back side. Just fell off. Okay, so the whole motor is loose now. Let's see if we can pull it out. There's nuts on both of them. Oh, spacers. Even worse. We'll put it back together the other way, if we put this motor back in at all. The keyway is a 3. Best approached here, but you could probably get at it any place. I was actually turning it. It was loose, but this is still tight, so I'll have to pry it off or get a puller or something. We're going to try a couple of pry bars and see what happens. Yeah, that'll do it. Just balance them out. It's not that tight. Gotta get a bigger pry bar. Here, a tool most of you guys probably have. Just like that. Shaft size is 13mm. Can you imagine if that was actually a 15? Oh well, let's see what we can do. Could it possibly be this easy? Look. 2 of the bolt holes line up exactly for dead center. And these, I just need to put it out just a little more space. And we'll use these nuts with big heads on them. And that should secure the motor. Then we got these pulleys that I've made for some other lathes and random fits, and look at this. It fits the belt, and it's pretty close to the right length too. It's maybe a hair longer, but I bet we can get it in there. I bet it'll work. If we have to, well, since the lathe's down, we'll just grind this off on the grinder if we have to put a little bit more, and then we'll make the kit probably with these pulleys. I'll just have to get a bunch of them and bore them out to the right size. We'll see what happens. Since the holes are already the right size, we're just going to hand tap them rather than setting it up in the jig. Just going to hand tap it. Most of you guys can do this at home with our base motor. Depending on how skilled you are or how much effort you want to put in it, buy the base motor. Probably need to cut this pulley. I might have them on the website, I might not. I probably will have them eventually. I'll probably have them mass produced. But anyway, get back to you in a minute. Okay, this would be straight up on the bracket. The old motor, the wires went in towards the lathe, up and behind. I don't know how much room there is there. I could go straight up, or I could go straight out. I have plenty of wire, so I'm going to go straight out, which leaves this adjustment for belt tensioning. So what I'm going to do is I'm going to put this in here just as a guide, momentarily, and this in here as a guide. And then we're going to look at these, and obviously we've got to cut those out. I'm going to use a die grinder and a bigger file than that, but a file. If you don't have a die grinder, this is entirely possible with just a file. It's about 1/8 of an inch. I'm going to mark mine with a reference line, estimated, of course. There is a little bit of play, so we'll split the difference about right about there, both sides, and then we'll grind them off and recheck. Okay, so we filed these, ground them and filed them. While I'm doing that, I realized, hey, I got a milling machine right over there. And by the time I clamp it in, I just finished these by hand. Got these 3mm thick washers. They're just the right thickness to make up for this. So we're going to put them right here. They will come in the kit. If you buy the base motor, you're going to have to locate your own. They're a little difficult to find. We already designated wires out the back, so we'll put it like this. Put these two in first. Just, as you notice, hand tighten barely because we want to get everything started before we do any tightening at all. And then we still want to leave the belt travel, so we're not going to tighten them any more than just snug them, just down a little bit actually, not even snug. Just enough so you see those bolts fit pretty good. Spin them in. Back them off a hair. There's your side travel. Hopefully it's enough. It's not all of it. And the motor's going to be slightly different. It's slightly larger, so it's going to have slightly less travel. Now we're going to want to fit the pulley. And I have this pulley already made. It should be just the right, and it should be just right all the way on. Keyway pulley. These are US set screws, so US Allen wrench, and just set it in. Not going to put any spacers behind because we've already decided it's going to go as far on as possible. Might be a little bit too long. Okay, a little more fidgeting and it's in. I've got it all the way pressed on. I'm going to tighten up the set screws. You know, I actually have the option to put the nut on here. I think I will. I mean, what the heck? All you need is the set screws. You don't need the nut. But I got it, so we'll put it on. So, spin on the nut. Lock washer? No. Just the nut. No lock washer. Not enough threads. Give it just a little. That's all. That's done. Time to put the motor in the lathe. So these bolts are not accessible to get at these at the back. So what we're gonna do, because they're gonna want to fall apart while I'm putting it together, so we're gonna stuff a little piece of modeling clay inside each one. That'll allow it to flex, turn, and move, but less likely to fall off. You also notice that everything's still kind of greasy and that I didn't really do a really good job of cleaning it up. There's a reason for that. You see, everybody makes their machines all clean, and then what happens is they corrode because there's no oil on them. And more importantly, let's try it on the other side and see what happens. Oh, that worked pretty good. More importantly is that the metal filings stick to oily surfaces. If you don't have an oily surface, then the metal filings blow around, and if they end up in one of the control units or in the motor, which can't happen with this motor, but it will with other motors, they make things burn out. So if the oil's just sitting there holding the metal filings in place, it's helping, why not? That one just poked through, so we'll just shove it in again. Okay, that's a good try. Moving on. Okay, now we're going to try to drop this motor in place. Wish me luck that it happens on the first try. You think it'll happen on the first try? I doubt it. Oh, it fits through. Look at that. Okay, first bolt. Wow, this is going to be too easy, I'm telling you. Just going to be too easy. Oh, mistake. Pull the wire through first. Maybe I can get it through there. Bet I can, because it's only bolted in with one. Lift it up. Slide it under. Aha! Look at that. So next, we'll do this one. And it's only going to get easier from here. Oh, look at that. Number 2. No. Yeah, you can't really get at them. You can get at this bottom one from the back, but the rest of them, that would be a no-no. There you go. Cut the thread. Okay, what do we got? Is it this one? Yeah. There's spacers in there. This one. Then we'll go get that ball socket. This one. Yeah, without that clay in there, I'd have had a big problem trying to get those spacers in. I wonder what they do when they build this lathe. I bet you they have a lot of other stuff off of it. Okay, how's it feel? Not a lot of adjustment. Might have to slot those holes. See if we can get the belt on just to where it is. See how she runs. Ooh. Belt went on. How's the alignment? Does this fit these two? Yeah. Let's get something to tension it with. This ain't the best, but it'll work if we're careful. Flat bar might be better, but this is what we got right now. So put this in here like this. Just put enough pressure on it. Tighten the belt. We don't want to damage the pulley because it's aluminum. That's too close. I can't believe how easy this is going to be. I think I'm going to have to grind that pulley a little bit, but let's see. So we set this in here to check alignment. End of the pulley. Yeah, it's... Oh boy, it's so close. That pulley could go in just a fraction. I think we need to have that pulley come in so that this lines up about right here instead. Let's do it. Okay, so we cut that pulley a little thinner, get the belt lined up right. Plugged in just one of our control units, programmed it to run the 2 horsepower with an external switch, and we're running. Not only are we running, sounds good again, no more funny noises. That means we can start cutting parts and we can make some more of those pulleys for anybody else that needs to do this. Whether we use this or wire it in, I think we'll wire it in and make it look good, but first, it's like, wow. Okay, let's look at the front and see what it says. Okay, what we're going to do some speed tests and see what we get with that pulley. Low speed is 98. Highest speed is 880. That's actually perfect for everything I do. I don't need the high speed. However, some people might. So it's probably a good idea to put the 2-speed pulley back on. I'll go recheck. Slowest speed 99-100. It says 96. That's all I need. I don't need the high speed. I'm probably going to offer it though, because other people are going to want it, even though they'll probably never use it. Oh, little update. I didn't program that yet, so I did reprogram it, and now our slow speed is 30 RPMs. That's motor speed. That's the lathe speed. I'll calculate that out later. Looks like 1.4 to 1 or something like that. 1,240. That's 4 to 1. 4 to 1. That's what it is, 4 to 1. That's great. 3,500. We're going to do a little performance test here. Okay, so we reprogrammed that. That's a piece of 3-inch bar stock, by the way. We'll do some cuts on it next, but I got the speeds down to real slow. All high. Now notice we've got the braking program. That's pretty fast, a full speed into a full stop. Next we'll try to set up for a cut. 32, we'll run it at 3,200. Okay, we're going to run this at 3,200 RPMs, that's 800 RPMs, 3-inch stock. We're going to bring it across. And we're going to let's do 10 thousandths cut. 5, 10, let's do 20. 20 thousandths cut. Notice nothing changes. So what we're going to do now is we're going to stop this halfway and we're going to do another 10 thousandths. So when we stop, we're going to go back here and we're going to add another 20, man, Let's add 20 more thousand. So this will be 40 thousandths when it reaches here. Let's see if the motor slows down at all. So 5, 10, 15, 20, plus 20. 20 thousandths cut. And it's going to step up to 40 thousandths when it gets to that spot. See what we think about that. See if the speed changes. Obviously not. It just picked up a little bit more amps to hold the speed at the exact same speed. This is going to benefit you with a lot smoother cuts than the old DC brush motor would do. I can't wait to get the rest of the electronics wired in onto this one. It's going to be just outstanding. So that's all the tests we're going to do on this machine. I've got to make parts. I'm going to make a couple more kits too while I'm at it to fix this lathe. Then I'll go into a second video where I'll show you how to wire in all the old electronics.